Okay, lesson 80, take 2. Okay, so yes, starting on example 1, finding horizontal asymptotes. Daryl had said that we look at the biggest powers, right? Compare the biggest powers. We have 4x to the 4th and 3x to the 5th. What do you notice about the biggest powers? Okay, yeah. Power of 4, power of 5. The denominator has the larger power. What's the rule when the larger power is in the denominator? What is that horizontal asymptote? 0. So the equation of the horizontal asymptote will be y equals 0. Because horizontal asymptotes are always y equals. What if the bigger power is on top? There is no horizontal asymptote. What if the powers match? Right. If these had been matching powers here, we would use 4/3 as our horizontal asymptote. If the bigger power had been on top, there'd be no horizontal asymptote. Since the bigger power is on bottom, there'd be an asymptote of 0. Up until this point, most of the ones we have been graphing have had the bigger power on bottom, so horizontal asymptote of y equals 0. Okay, let's look at example 2. Now I'm going to kind of go through the 4-step process up above. I mean, the idea is just make sure you think about each of the pieces, right? So if I think about option 1, finding any horizontal asymptotes. What are your thoughts on this one? Well, what do we do? Horizontal asymptote. No, I'm starting with horizontal. I was like, I am really mystified by what Nathan is saying back there. What do I look at for horizontal here? Okay, the limit at infinity. Basically, we're always looking at the powers. What do you notice about the powers here? Yeah, you're thinking about the fact that it is x squared over 2x squared. And you could say, okay, the limit as x approaches infinity, the powers match, so what's going to happen? If the powers match, we use the coefficients, which are 1/2. So we're going to have a horizontal asymptote of y equals 1/2. So instead of having the horizontal asymptote that is the x-axis, it's going to be y equals 1/2. Now, step 2, I'm ready to talk about vertical asymptotes. Yeah, we got to solve the denominator for x, which means we should probably take some factoring steps here. What do you know about negative 5x plus x squared? Does it factor? Is there a GCF at least? And that counts as factoring, and I still want to do that just in case. Because keep in mind, if there's a factor on top and bottom that cancels, instead of a vertical asymptote, it'll make it a whole. So if I factor an x out on top, what do we have left?
Could turn it into x minus 5.
I do like that, Trevor. X minus 5. You could write it as negative 5 plus x, but I think we all prefer x minus 5. What about the denominator? There's a GCF of 2. That leaves me with x squared minus 4. Does x squared minus 4 factor? Yep, x minus 2x plus 2. So still a 2 there. X plus 2. X minus 2. Do I have any factors that cancel? No. So no factors that cancel. So, thoughts on the vertical asymptote? Okay. When we set the denominator equal to 0, what kind of vertical asymptotes am I getting?
Plus or minus 2.
Yeah, we're going to have x equals 2 and x equals negative 2. Okay. Number 3, how do we find zeros? Yeah, zeros are the numerator equal to 0. And since we've already done all of that lovely factoring work, what kind of zeros do I have? 0 and 5? And item 4 says find the slant asymptote. What are you saying, Daryl?
So we can ignore it.
Okay. We can ignore number 4 because there are only slant asymptotes if there's no horizontal. Since there was horizontal, there's no slant. Okay. Got all of our information to graph it? You guys know I like to make these graphs very long. Okay, let's see. What kind of things do we need on here? We have to, in the positives, we have to at least label to 5, right? And the negatives, at least negative 2. Some important numbers to label. 2 and negative 2. And what am I going to put at 2 and negative 2? Vertical asymptotes. I'm going to have zeros at 0 and 5, which means I like to put points there to represent that, right? What about this fun horizontal asymptote? Yeah, y equals 1/2. So that is just a smidge above the x-axis. When it's the x-axis, we often don't draw that horizontal asymptote in. I would encourage you to definitely draw it in here because it's not the x-axis. Okay. And let's see, we got horizontal, both verticals, we got our zeros, we got no slants. Okay. Thoughts? Where do I begin? Do you remember how to decide?
Since the biggest power of the numerator is positive, we start above the x-axis.
Okay. And I wouldn't necessarily say that just because it's the biggest power in the numerator. I'm trying to think.
Well, that's all that will go out front.
Yeah. But, I mean, it's also in general because if you had a negative on the biggest power in the denominator, that could be pulled out to be a negative. But the fact that when these are factored, that's the easiest way to look at it, right? All my x's are first. X-axis, but close to the x-axis, actually puts us in between the axis and the asymptote. It's weird, but it's the truth. So we're going to start running along here, running along the x-axis between the axis and the asymptote. Now what happens when I get to 5? We're going to have to cross through the axis. And if you look in the calc there might be kind of a bump or something. And then what's going to happen? We switch signs, right? So since we ended in the negative, we're now going to start in the positive. What would change that is if we had a factor squared, right? I think that was the last thing we learned. So if here this 2 comes from x minus 2, if this was an x minus 2 quantity squared, that's what would cause me to stay negative. But in this case, we're going to go up here and start from the positive. Now, what about horizontal asymptotes in the middle of the graph? You can cross through horizontal asymptotes in the middle of the graph. Okay? Vertical asymptotes we're never going to cross through. Horizontal asymptotes in the middle of the graph you can. Horizontal asymptotes are designed to describe your end behavior. So the places you'll never cross the horizontal asymptotes are off to negative and positive infinity. So yes, we're going to cross through this asymptote because what do we have to do? We have to cross through 0 here. So this is going to be your typical kind of cubic looking function there. And now what? Switch signs. And this time we're going to end up running alongside the top of that horizontal asymptote. And now you cannot cross that horizontal asymptote because we're going off to infinity. Okay? Got it? If you don't have questions, let's try the next one then. Example 3. Number 1. Thoughts on horizontal asymptotes? None, because the bigger power is where? In the numerator. No horizontal asymptotes if the bigger power is on top. So since it's x squared and x, no horizontal. Okay, vertical asymptotes. How do I find vertical asymptotes? Denominator equal to 0. So challenging on this one. What do we get when we set this denominator equal to 0? X equals 0. Number 3 is zeros. Excuse me. How do we find zeros? Set the numerator equal to 0. So in this case, my numerator is x squared plus 1. Does that factor? No. And if we set x squared plus 1 equal to 0, and we start solving, what happens? We get imaginary numbers, yes? Okay. Can we have imaginary zeros? I mean, you can have imaginary zeros, but they're not going to be physically present. And so in that case, what do we know about zeros here? There are no zeros. Okay, no real zeros at least. Thank you very much, Reese. Okay, this is shaping up to be an interesting graph then, huh? What's number 4? Slant asymptotes. Do we have to consider slant asymptotes this time? We sure do. Okay. What's it say about slant asymptotes? Dividing the numerator by denominator. So that means we're taking x squared plus 1 and dividing by x.
Is long division still fun?
Are you guys complaining?
After they find decimals. No. There aren't decimals here. Yeah, there are.
Okay, so let's practice some long division here for a moment. In the box is x squared plus 1. But in long division with polynomials, remember you can't have any missing place values. So x squared is good. What's the missing place value here? Plus 0x plus 1. We're dividing, and this one's kind of an awkward one to divide by, because we're dividing by x. More often than not, you think about dividing by x plus or minus a number, right? So I think for the benefit of review, I'm going to go ahead and say x plus or minus a number, just because I think it'll be more, reality of what you're used to doing. So I don't know how much you recall about when I last taught this to you, like 2 years ago probably. You might have reviewed it in pre-cal. I don't remember. It was mostly Algebra 2 though. Okay. X times what is x squared? Just x, right? iPads is making a bunch of noise. Okay, so x times x squared. Now, since the way I have it set up, we're going into 2 terms, so we put it over the second term. Multiply now. X times x is x squared. X times 0x, 0x. And then you subtract. Long division says we subtract. X squared minus x squared and 0x minus 0x is 0. Bring down the 1. How many times does x go into 1, or x times what is 1? Okay, you can say 1 over x, and the idea is really you could put a 0 there and say it doesn't go, right? But then if we put a 0 there and say it doesn't go, we still have to add our remainder on. What's our remainder? 1 over the divisor of x. So either way, this is plus 1 over x. So our slant asymptote is y equals, officially, you can, since it's divided, it's x plus 1 over x. Now, that 1 over x is not really anything. And so when we graph this as a slant asymptote, you just graph y equals x, that main part. That's what we're going to be graphing as our slant asymptote. Okay. Let's look at this graph. I didn't leave as much room over here because it's not a really long. Whoa! Now my Zoom decides to all of a sudden wake up. Okay. No horizontal asymptotes to put in. Vertical asymptote of y equals 0 means there's an asymptote on the y-axis. No zeros to put in, which means this graph will never cross through the x-axis. And we have a slant asymptote of y equals x. What does a line y equal x look like? Yeah, it's your perfect diagonal line. It goes through 0, 0, and has a slope of 1, right? So it's going to go through those points 1, 1, 2, 2, 3, 3. I'm freehanding that line. We're not going to get that precise. Okay. That's what you got. Now you got to draw a graph. Okay, we have to start off positive. And that's where this one is a little bit different because we start off positive here, what's going to eventually have to end up happening? If you start off right here positive, right above the x-axis, it ends up where you'd have to cross through the x-axis. We're not allowed to cross through the x-axis. So we actually end up starting, slant asymptotes make things a whole different world. What we're actually going to start is we're going to start along the slant asymptote here. And we're going to run down along the slant asymptote. And then what's going to happen when we hit that vertical asymptote? We're going to have to go back up. And so you're going to have a curve that does something like that. Now, what happens when you hop over the vertical asymptote? You're going to be on the bottom and switch signs. Can we do the same thing down below? Where you're running along that vertical asymptote, then you hit the diagonal asymptote, and you're going down. Okay? Notice we didn't cross any x-axis, so we don't have to worry about any zeros. That's how a graph like that works. Those slant asymptotes, I'll be honest, this is the typical type graph you will see with a slant asymptote. Okay? Questions? One more if you don't have any questions then. Same steps. Horizontal asymptotes. Oh, that fun answer of none. Why are there no horizontal asymptotes? Bigger power is on top. You just know what that means about the end then, right? Okay. Step 2, what do we do next? Vertical asymptotes? Do we have any vertical asymptotes this time? Yeah, vertical asymptote at x equals 2. And that's because we are setting that denominator equal to 0. Okay. Number 3, any zeros? Nathan says yes. Where do we have zeros? Yeah, 1 and -1. This time you're saying the numerator equal to 0. And you could either set x squared minus 1 equal to 0, add the 1 over, take the square root, and remember you need a plus and minus. Or x squared minus 1 can factor x plus 1, x minus 1. Any way you go about it, you have zeros of 1 and -1. And what about 4? Do I need to consider slant asymptotes?
Sadly, yes.
Sadly, yes. Now, okay, last time I went the good old typical long division route. And depending on your denominator, you will have to go long division route at times. I have an alternate option for you here. Can we try synthetic? Synthetic division works when you're dividing by a linear factor. X minus 2 is a linear factor. So you ready for some synthetic division review?
Yeah.
What goes in the box? Since we're dividing by x minus 2? Yeah. Set equal to 0, and so then a 2 goes in the box. What numbers go along the first row? The coefficients. So 1 represents x squared. Placeholder 0 to represent x to the first, and then a constant of -1. Does this sound familiar, I take it? You guys used to like this stuff. It's just a matter of remembering it.
This one's the one I actually know how to do.
Yeah, I like this a lot more than
Okay, good.
long division.
Drop the 1. Multiply. 2 times 1 is 2. Add. 0 plus 2 is 2. Multiply. 2 times 2 is 4. Add. -1 plus 4 is 3. What is that 3? That is your remainder. So if we are writing this out officially, the 1 represents 1 what? X plus a whole number of 2 plus officially, how do we represent that 3? 3 over the divisor of x minus 2. What are we going to graph as our slant asymptote? Y equals x plus 2. Okay? So yeah, use that synthetic division when you can. Okay. Let's see. We need to put what kind of things on this graph? No horizontal, a vertical asymptote at 2, zeros at 1 and negative 1, and a slant asymptote at x plus 2. So that means a slant asymptote at y equals x plus 2 is going to have a y-intercept of 2, and then it's going to have a slope of 1, up 1 over 1. I always do this every time. Use logic to figure this out, guys. Where's part of this graph going to have to be?
Where the other graph is.
Well, yeah, where the other graph is. I was thinking about the zeros.
Well, that too.
I mean, if you look at the fact that it has to go through these zeros here, yes? Can you see that shape there? So it's going to have to be doing something like that. Which means where's the other part of it? And that's where the other graph is. Not to be confused with the graph above. Sorry, I do that every time. Okay. In homework, number 2 is going to become number 5 from 77. Okay. So make note of that. And let's check home.